In notes 6.2 example 14, we're given another application problem that uses right triangle trig. So we're told that a lightkeeper was standing at the top of a lighthouse 65 feet above the ground. Then he looks down and he spots a boat in trouble at an angle of depression of 35 degrees. And we're asked to find how far the boat is from the shore. So we need to discuss a little bit about what angle of depression means, or the other alternative that we might be told is angle of elevation. So the important thing with these angles is they are measured from the horizontal. Okay, so an angle of depression means you'll take a horizontal segment and then you'll go down from that from the horizontal. So this would be an angle of depression. And if you have an angle of elevation, you'll take the horizontal and then you'll be going up from that horizontal. So angle of elevation. So this is just some background information. And you can think about the horizontal means you're looking out at the horizon and then you're either going down or up relative to the horizontal segment. So let's go ahead and solve this problem. So we're told that the lightkeeper, the lighthouse keeper is standing at the top of a lighthouse that's 65 feet. So I'm going to go ahead and draw a line for the lighthouse, and that is 65 feet tall, so 65 feet. And he looks out and he spots a boat in trouble. So here is a boat that's in trouble, and he looks out and he sees at an angle of depression. So this would be the horizontal, and the angle of depression is going down from the horizontal to this boat, and that angle of depression is going to be this angle right here. This is 35 degrees, and now we've created a little right triangle. You'll note that that 35 degrees is not in our right triangle. So the angle in our right triangle is this angle down here. But we know that we have parallel lines. The ground and the horizontal line that we drew are parallel. So we have parallel lines cut by a transversal. And we can see that these two angles here are actually alternate interior angles. So theta is going to be 35 degrees. And now we have an angle in our triangle. So we're ready to solve this problem. We have it set up. So I'm going to label the side lengths of my triangle relative to that 35 degree angle. So the side opposite the right angle is going to be the hypotenuse. So this is the hypotenuse. The side opposite the 35 degree angle, which is the 65-foot length, side length, is going to be labeled opposite, and the remaining side is adjacent. And we're asked to find how far the boat is from the shore. So that is the segment down at the bottom of the triangle. I will label that X. So we're interested in finding the length of the adjacent side, and we know the length of the opposite side. So if we think about our trig ratios, so TOA, the one that relates the length of the opposite and adjacent sides is going to be tangent. So we can say that tangent of 35 degrees is the length of the opposite side, 65, over the length of the adjacent. And now to solve this, we'll multiply both sides of the equation times x, and we'll get x tangent 35 degrees is equal to 65. And to isolate x, divide both sides of the equation by tangent 35. So x is equal to 65 divided by tangent 35. If you enter that into your calculator, you'll find out that it's 92.8 feet. So we can say the length, oh, no, here it's the boat. The boat is 92.8 feet from the shore.